Hello everyone, welcome to the 24th video on Snowpro core certification series. In this video, we are going to discuss about semi-structured data transformations, meaning we are going to discuss about how Snowflake is going to handle the semi-structured data, what are all the various options which are available within the Snowflake to do the transformations on the semi-structured data. Without further ado, let us try to understand this. First, let us try to understand the semi-structured data. If you are already part of the data warehousing or data engineering background, you might be aware of this. But for the better audience, it is good to cover this as the initial topic. We all know there are three different forms of data. One is the structured data, other is the semi-structured data, and the final one is the unstructured data. So structured data is the one which has the fixed schema. For example, if you take an CSV file, that CSV file will be having the rows and columns similar to a table where we can define a fixed schema. But in the case of the semi-structured data, we don't have a fixed schema. It's a partially structured data that doesn't follow the tabular structure, which is associated with the relational databases or other forms of data table. However, it does contain tags and metadata to separate semantic elements and establish hierarchies of records and fields. A slightly trickier definition, but let us try to decode this and let us try to understand this. First, let us try to differentiate between structured data and semi-structured data. If you see, as we already discussed, semi-structured data does not require a prior schema definition like the structured data does. Without a predefined fixed schema, semi-structured data is more flexible and free to evolve over the time as new attributes are added. This is one important thing to note. It gives you more freedom. Say nowadays, if you see, most of the system generated messages are in the form of the semi-structured data like JSON, or similarly it's like ORC or Parquet formats, where the schema evolution is pretty common. So if you want to evolve your schema evolution meaning as simple as it is, say I want to add new fields, I want to remove some of the fields, those things are very easy with the semi-structured data. Semi-structured data also supports hierarchical data structure that contains the nested information. For this to better understand, let us take this and we will decode this specific thing. This is a simple example of a semi-structured data. If you see here, it starts with the curly brace and ends with the curly brace. Here customer ID is some value. Within that there is a name. That name is inside, it is having two other fields. It's a dictionary, what we can call. A name is a dictionary. Within the dictionary we are having first and last fields which are AAA and BBB. And then you can see address is again a dictionary where it contains street, number, city, state, etc. Then you can see CC on file and first order. This is how a semi-structured data looks like. This is an ordinal JSON representation of the data. Here you can see, say I want to add a new address field. That is pretty easy. Say I want to add another full name field for the name. That is also pretty easy. Say I want to remove CC on file. That is also pretty easy. This schema is very freedom wise. It is very easy for you to evolve. That is the reason why semi-structured data is very common across the industry. And another example here, if you can see, this is the another example here. Same like the previous one. Here within the address you can see city and street. These things we can call it as value. These are all key value pairs. City is the key, London is the value, street is the key, Oxford Street is the value. But here you can see there is a square bracket. Square bracket is the representation of an array. Array, you might be aware, if you are from the typical programming background, you know what array is. It's a collection of common fields. Here if you see, phone is the one wherein which Apple iPhone, Google Pixel, Samsung Galaxy are of phone types. So we are encapsulating that as an array using the square brackets here. So there are various ways by which we can represent this. When it comes to the file formats, what are all the file formats which are used very widely across the industry? Currently, if you see, these are all close to around 5 file formats. First one is the XML, which is the extensible markup language. It is easy to use markup language that allow users to define tags and attributes required for storing data in the hierarchical form. JSON is the very common form of a semi-structured data, which is the JavaScript object notation. Collects the semi-structured data from varieties of devices like IoT devices, web browsers, smartphones, used to transfer the data between servers and apps or internet connected devices, which is very widely used. Coming on to Avro, these are all some of the file formats which is useful to store the bigger amounts of data. Say it as a big data. Avro originally developed with Apache Hadoop. Avro is the remote procedure called RPC framework for data serialization. When it comes to the other format, which is the optimized row columnar, again a columnar way of storing the data designed to achieve more efficient compression and enhance the performance for reading, writing and processing data over earlier Hive formats. If you all know, Hive is again another big data based framework which is very helpful in querying the big data. So the ORC is one of the formats which very well supports the Hive. Finally, we are discussing about Parquet, again another widely used format, which is the columnar storage file format. It is ideal for working with complex data in the large volumes. Say it is a big data, and it features different methods for efficient data compression and encoding data types. Now we are going to look into what are all the data types which are available within the Snowflake, which helps us to store the semi-structured data within Snowflake. First, we are going to discuss about array. Again, it is pretty evident if you are from a typical programming background or whatever, if you are from the computer science background, you must be aware of array. The same thing we can do using the array data type within Snowflake. It is similar to array in other languages. Each element is accessed by specifying the position in the array. Pretty evident. Each element is accessed by specifying the position in the array. Again evident. Each value in the semi-structured array is of type variant. We are going to see what variant is all about. Values and other data types can be cast to variant and then stored in an array. As simple as it is. If you see, here is the example. We are creating an array table with ID and value as array. Here is the data type of array, and we are inserting into that array example. Here for ID I am just selecting 1, and for sending the value into array I am using a function called array construct, where I am passing 10, 20 and 30 as the values. This array constraint function by itself will convert the values into the variant data type, and then it will push it against the array data type. So this 10, 20 and 30 will be stored in the variant data type within this specific value called array. As simple as it is, I don't think it's a complicated one to understand. Moving on to the second construct, which is the object data type, similar to the JSON object, which is called a dictionary or a hash or a map in many other languages. In the previous diagram we looked into that. If you see a dictionary there, if you want to store the values within the dictionary, ideally a key value pair, then you need to utilize the object data type. Contains the key value pairs. In the Snowflake semi-structured object, each key is a varchar and each value is the variant. As simple as it is. Snowflake does not currently support explicit typed objects. The maximum length of an object is 16 MB. Here you can see an interesting example here. Here we are just trying to insert the data into object example table, where we are using object construct function. Again, this is another function which helps you to construct the object. 13 is the key and this 13 is the value. So 13 is the key, which is the varchar, and this 13 is the value which needs to be variant, as we discussed earlier. So we are utilizing this double quotations to convert that. This is the casting methodology. There are many ways by which you can do the casting. Casting meaning converting from one data type to other data data type. Here 13 is the numeric data type. We want to convert it into the variant data type. That is the reason why we are using this. Similarly, if you see 0 is the key and this 0 we are converting it to variant, which is the value. So this specific object contains two fields, 13 and 0, with the values of 13 and 0. The 13 and 13, I hope you are able to understand, the value is the real value here, right? So this is how you can represent an dictionary within Snowflake using the object data type. Finally, we are discussing about a variant data type. This is very, very widely used within the Snowflake ecosystem. So you need to understand this very clearly. A data type that can hold any value of any other data type, including array and object. Try to understand. So you can store any value. Say, I want to store the entire semi-structured data, which contains the dictionaries, which contains the arrays. You can utilize this variant field. So you can store the complete semi-structured document within this variant field. It is used to build and store the hierarchical data. Hierarchical data is as simple as it is. If you see in the semi-structured data, it's differentiated via the different hierarchy. So we can see as the previous example, if you see customer ID is there, and then within the address you will be having the address fields. So similarly you can hierarchify the data. So everything will be stored within the variant. A maximum size of 16 MB. We discussed this in our previous videos as well, but this is very important to know. 16 MB of uncompressed data. So what it happens to be if I exceed that 16 MB, again we discussed about the strip outer array function as the part of our previous videos. So you can utilize the strip outer array file format option to remove or to reduce the file size beyond, if it is going beyond the 16 MB size. To convert the value or from the variant data type, you can use the casting methodologies. This is what which we discussed in this example as well. You can use the two variant casting function as well. That is also very evident. Here you are seeing insert into the varia v, which is the table. Here we are utilizing the two variant to convert that value into the variant field. Parse JSON, meaning this is the JSON value. Here key and value is there. That is in the form of the JSON format. So we need to parse the JSON format and then we need to utilize the two variant to cast it into the variant field. As simple as it is. By doing so, all these values, key 3 and value 3, key 4 and value 4, will be stored inside that varia table, which contains a field with the variant data type. Next, we are going to discuss about an interesting things within the semi-structured data, how we can query the semi-structured data. So far we discussed about the data types. We use array, we use object, we use variant to store the semi-structured data. How I can query my semi-structured data? To understand this, we need to take the example, and then based on that example we will try to understand. Here we are just creating a table which is the car sales, which contains the source field as the variant column. We know within variant we can store all forms of data. This is my data. If you see, this is a semi-structured, typical semi-structured data. It starts with the customer. Within the customer you are having an array, and then within that array you will be having the address field, name field, phone field. That array got completed, and then there is a date, and then there is a dealership, then there is a salesperson, which is the dictionary which contains the ID and name, and then there is a vehicle which contains an array. Within that there is an extras which contains another array. If you see, it is the completely complicated semi-structured data set. But now we will see how we can utilize varieties of options within Snowflake to query this data. Currently, this data is stored inside this SRC field, which is the variant data type. First, let us see traversing of the data using the colon notation. Here, SRC dot colon dealership. Now we are just trying to see this specific value. This is in the first hierarchy itself. So directly you can use SRC colon dealership from car sales order by 1. If you do so, whatever the value which is there, value view auto sales will be returned. So for the top element, it is pretty easy. We can use the colon notation. There are another different types of notations like dot notation and bracket notation as well available. We are going to see that. Here if you see, I want to see the name here, right? this name of this field. Sorry, I want to see this name. So this name field here. What I need to do, the salesperson, inside the salesperson dictionary, there is the field of name, right? For this to happen, what we are trying to do, src colon salesperson will go inside this salesperson, and then we are specifying dot name to get the value from the dictionary. By doing so, we will get the value of Frank Beasley here, as simple as it is. Then now we are moving on. We are just trying to do the same using the bracket notation. We can use the bracket notation as well. SRC salesperson name. Obviously, the same value of Frank Beasley will get returned out. Now, returning the single instance of the repeating element, this is very interesting thing to know. If you see this specific one, right, here the src of customer of 0, this is the array representation. You know it very clearly. Customer 0 of name and src of vehicle of 0. Here, if you can see, the vehicle value contains all these values, and the customer 0 dot name contains the Joyce Ridley. So, as simple as it is, if you see, the output of this will be Joyce Ridley, which is the direct name, and then if you see customer, within the customer array we will be having that name, and then within that vehicle we will be having this complete information. That complete information will be returned out. So this way as well we can return the value. Finally, we are just seeing the casting options which are available here. If you see src of dealership, directly we are pulling the dealership value, and now we are converting that dealership into the varchar value here. So using the double colons, now the output of this will look something similar. Here, since the first one is in the string value, it is coming as double quotes value view auto sales within double quotes. But as we converted that into varchar, now it is coming it in the normal value here. Now we are going to discuss about semi-structured data function. So far we discussed about data types and how we can query the semi-structured data. Now within Snowflake there are lots and lots of semi-structured data functions which are available, which will help us to modify or extract the data from the semi-structured values. So far we discussed this to a greater extent on the array construct and object construct. Those are all some of the functions which are available. So ideally, what these things do, it is useful in parsing the JSON and XML data, creating and manipulating array and objects. That is using the array construct and object construct, extracting values from the semi-structured and structured data, example from an array, object or map, converting, casting semi-structured data type and structured data type to and from other data types. This is all about casting, determining the data type for the values in the semi-structured data, that is the type predicates. So all sorts of things are possible using the native Snowflake semi-structured data functions. Here we will see some of the examples. Here first is the parse JSON and to JSON. This is helpful to parse your JSON value. Here we are creating the JDemo2 table, which is having varchar of 1 in the varchar and variant 1 in variant. Just for naming representation, they are utilizing the same. We are inserting it into the values of, see, if you see pi and 3.14, right? The pi is the key and 3.14 will be the value. We are just inserting that specific value into the varchar, and then using the same value, we are utilizing the parse JSON, and then we are converting that into the JSON and storing it into the variant using this update command. So as the resultant of this, if you see, if I fire this query against that, varchar of 1, parse JSON of varchar of 1, and then if you see variant of 1, to JSON of variant of 1, you can see different set of results. So ideally we stored this value only. The parse JSON resultant output will convert that into one typical dictionary, and then you can see variant of 1 is the similar one which we did in the update command. So again it's the similar dictionary. Now you can convert that into the JSON value again using the to JSON construct. So parse JSON is used to convert the normal one into JSON, and to JSON will convert that into the specific JSON for statement again. So this is the ideal example which you can use. Moving on, these are all the things which we already saw. Array construct. Array construct is used to construct an array. So whatever the elements which you pass as the part of that specific function, it will construct that into array, and similarly you can see the object construct. This will create a dictionary. A equal to 1, A is the key, 1 is the value, B is the key, B is the value. Since we are passing null as the value to C, it is not represented here. But there are lot many functions which are available. You can go through the Snowflake documentation. As usual, this will be available as the part of the description. So far we discussed some of the functions only, but if you can see here, there are lot many functions available here. Please spend some time and try to understand what are all the things which are predominantly available for you to utilize these functions and convert the semi-structured values based on your typical use cases. Now we are going to discuss about flatten function. This is again one of the function, but in the Snowpro study guide there is a clear mention about flatten, so we need to understand flatten to a greater extent. So flatten, what exactly flatten does? Flatten explodes compound values into multiple rows. We are going to discuss this as the part of the example for your better understanding. It is a table function that takes a variant or object or array column and produces a lateral view. That is what it is represented here. So it takes in some values and it will generate the rows out of it. Say if you want to take a semi-structured data and convert that into a structured data, then flatten is the ideal function for you. Can be used to convert a semi-structured data to a relational representation. That is what we discussed. This is the syntax. It takes an input in the form of the expression which contains path outer equal to true or false, recursive equal to true or false, and then the mode. So let it be like this. Let us see an example. But what are all the output of the flatten? Flatten will generate the output in specific format which contains all the 6 fields: sequence, key, path, index, value, and this. These are all the values which got returned if you utilize the flatten. So you can see sequence is the unique sequence number associated with each input record. Key for maps of the object. You all know, right? What is the key? This column contains the key of the exploded value. Path is the path of the element within the data structure which needs to be flattened. Index is the index of the element if it is an array, otherwise it's null. Value is the value of the flattened object element. This is the element being flattened, useful in the recursive flattening. For example, if you see this one, select course name from table, flatten, input, select src course name from course. If you remember, this is the semi-structured data. Within that semi-structured data which is stored in an variant field or something which is having the course name as the field. I am just selecting that course name alone as the input, and then I am using the flatten to flatten that data, and I am selecting the course name from the table. The output will look something like this: row equal to 1 and the course name equal to Snowpro, row equal to 2, Snowpro advanced. Now we are able to convert the semi-structured data into unstructured data using this specific flatten command. The another one is the lateral flatten, which is a slightly complicated one, but let us try to understand what lateral flatten is all about via an example. Here we are creating a table called as persons, which contains a column and the parse JSON of column 2 as C. From values, we are giving the complete semi-structured value here. So the column 1 is mapped to this specific value 127.12555, but this specific parse JSON of column 2 is completely mapped to this specific semi-structured data. As you all know, it is having all sorts of dictionaries, all sorts of arrays and everything. Now we are utilizing the multiple instances of lateral flatten in the from class to get the output of this specific thing. Now how the lateral flatten looks like, you can see select id from id, and then we are taking the value f dot value as contact. So here we are utilizing the lateral flatten and we are inputting that, and path equal to contact. So the contact which is mentioned here is mentioned in the path. So f dot contact, f dot value as contact, you need to remember that, and then f1 dot value type as type, and then f1 dot value content as details, right? So this type and then this content, this type and content is getting used here using the lateral flatten. So here this F1 we are doing the lateral flatten on the business type. So each and every place we are passing different as the input. Here the contact as the input for F and the business as the input for F1. Let us see the output, which is very interesting to know. Here first, as we flattened using the contact, it will do that contact stuff for F, and then as we do the flatten using the business, it will do the flatten for the business. Here since it's the contact value, here if you see the complete set of business, whatever which is available within that business specific stuff within the dictionary, everything is returned. As F1 is all about the business alone, only whatever fields within the business is getting returned. Now if you see the type value for this specific business, you will be having phone and email as type. So for each and everything, one record got returned. For phone, one record got returned, and for email, one record got returned. For the phone, the value of 5551234 got returned, and for the specific email, j.smith@company.com got returned. By doing so, you can very well explode the semi-structured data to a macro level. Macro meaning to whatever extent you want to do by utilizing the lateral flatten within the Snowflake. With this, we come to end of this video. I hope this video has been informative for you. Please do write lot of comments. That will be very much needed for me to enhance the course contents. Thank you very much for watching this video.